Hi, in this video I'm going to show you how to solve a problem for hypothesis test for difference in means of two populations when you don't know the population standard deviation. Okay, so let's take a look at this problem here. Remember this problem we talked about in the last video. We have a computer software package and we have a new computer software package, and we want to know if this new computer package takes less time, the mean project completion time for the system analysis is lesser, so it's less than the mean project completion time for the current technology. Okay, so remember we have two samples. This is analysts using current technology. This is analysts using the new software. The sample mean for the current software, the sample mean for the new software, and this is the sample standard deviation. Sample standard deviation, so you know, is a t-score problem. And let's follow my steps here. I have the steps that I proposed. You can watch the last video, I'm going over them, but you can go over the last video. I detail each one of these steps, okay? So let's take a look at these steps. Let's use the critical value approach. So the critical value approach developed the null and alternative hypothesis. So if you take a look, let me show you. Where is it? Hold on. So if you use this one here, these are the hypotheses for this problem. So I want to know if the new software technology take less time than the current. Okay. So this is this problem turns into this type of hypothesis. Alternative hypothesis is an upper tail test. So I described more details about this in the previous video. Okay, so step 1 and step 2 are done. Is an upper tail test. Specify the level of significance. The level of significance 0.05 is upper tail, so let me do that. Next page, step 3. Let's do step 3. Alpha is 0.05, and according to my, if it is upper tail, I'll do 1 minus alpha is equal 1 minus 0.05 equal to 0.95. Then in step number 4, I have to compute the degrees of freedom using the sample size 1 and sample size 2. I have to compute this degrees of freedom. And if we go here to the problem, let's take a look at the degrees of freedom. The degrees of freedom are here, are 21. I'm not going to compute in front of you, otherwise it's going to take too much time. The degrees of freedom is 21. Step number 5 is then find the t-critical. Okay, so step number 5 is find the t-critical. Here, find the t-critical associated with the level of significance from 3. So use this formula, t inverse the probability I found here in this step 3.2. So let me show you what you have to do. You have to do equal t inverse, and then this 0.95, and then 21. You have to do that, okay? In Excel, these are the numbers you plug in, and the result is, I'm not going to do that in Excel because to save our time. Let's take a look. The t-critical, let me see, t-critical, where are you? Okay, I can find, let's do an Excel, okay? So the t-critical is equal t inverse, open parentheses, and then 0.95, and then 21 degrees of freedom is 1.72, okay? So if I go back here, it's 1.72. So if I draw, it's an upper tail, is a positive number, okay? 1.72, this is the critical region. If the t-statistic is higher than 1.72, I reject the null hypothesis. So, okay, so if the t-statistic is higher then the t-critical, I reject the null hypothesis. So let me open, okay, let me do it here. The next step is compute the t-statistic. Let's take a look. My sixth step is compute the value of the t-statistic. We have the t-statistic computed here, okay? So I'm not gonna do that in front of you. So the number is 2.27, t 2.27. We have two t's, okay? This is the t-critical, and this is the t-statistic, okay? So this t-statistic is higher than my t-critical, so it's in the critical region. This is called critical region. So I reject the null hypothesis, okay? So what's the null hypothesis? The null hypothesis is this, so I have reject that, so the difference is higher than 0. This means, I'm gonna wait for, okay, so I reject this one and accept the alternative, which means that the new current software takes less time than the new software takes less time than the current software. So this is the conclusion, okay? So this is how you proceed with the steps to come up with the rejection region and finish the problem, okay? Now let's do that using the p-value approach. Let's do both approach right now in the same video, okay? So these are the p-value approach. First step is develop the null alternative hypothesis, determine if it's lower, upper, or true tail. Okay, we did that. I'm not gonna do it again. So here's steps 1 and 2. Okay, and I determined that's an upper tail test. Okay, that's the same hypothesis. And specify the level of significance. Let me skip here. So step 3, now is the p-value approach. Okay, p-value approach. Okay, this is the p-value approach. The level of significance is 0.05. Step number 4. Step number 4 is collect the sample data, compute the value of the t-statistic. We know that the t-statistic we computed is 2.27, right? 2.27, I believe, yeah. So step number 5 is compute the degrees of freedom. We know the degrees of freedom is 21. Step number 6, find the probability of the t-value, the t-statistic I found here on step 4, okay? In lower tail, I use this formula. So step number 6 is equal 1 minus t dist, and then 2.27, I'm sorry, 21 degrees of freedom, and comma 1. So this is, let me wait before it shows up here. Okay, so this is what I have to enter in Excel. This is what I'm going to do. Let's take a look at the slides and see. So these are the hypotheses. The same one we have is an upper tail test, p-value approach, 2.27, and then the degrees of freedom. And then this is using the table. You don't need to use the table. Let's use the Excel. So it's equal 1 minus t dot dist, open parentheses, and then 2.27, that's the value of the t-statistic, 21 degrees of freedom, and 1. So it's 0.01, the probability value is 0.01. So this is p-value is equal to 0.01. Final step is I compare the p-value with the alpha level. If p-value is lower than the alpha, reject the null. Reject the null, okay? So it is small. P-value is 0.01, is smaller than 0.05. I reject the null hypothesis. This is the same conclusion we found here. Reject the null hypothesis. Okay, so both approaches, of course, give the same answer. Okay, so let me wait. So both are reject, okay, both approaches. And the slides are like showing the same thing. I just prefer to do by hand to help you understand how to organize the problem and go over about the problem, okay? So that's it. In the next slide, I'm going to show you how to solve this problem using Excel and the raw data, because we have the raw data, okay? So this is like how you work on the problems about hypothesis tests for two population means when you don't know the population standard deviation.